Good morning, I am Antonio Carrillo from the University of Malaga, Spain, and on behalf of my college, I'm going to present this work called Standardized Power Values of some tested solar cookers following the linear regression of ASAE S580.1 Standard protocol and the linear regression associated with the Hottel-Whillier-Bliss formulation. Experimental testing of solar cookers is important to rate their performance. In the picture we can see the testing of a funnel solar cooker in the University of Malaga, Spain. One of the most widely used protocol is the ASAE S580.1 Standard, testing and reporting solar cooker performance. It is intended to be a common framework for sharing results for researchers and users. Its goals are to make testing as simple as possible, to present cooker performance in widely recognized units, and to obtain information predictive of cooker performance. It's important that a result should be repeatable. This standard sets limits for environmental conditions, specifies test procedures, specifies how the data processing should be made, and indicates the performance parameters to be reported. The authors have performed many tests based on this protocol, and we have recently found what we believe to be a methodological error in the standard. We will now describe the standard's data processing and point out what the problem is. Let us take a test of a funnel solar cooker as an example. This test took place on February 11th, 2020. On the left, there is a picture of the test and there is a table with the relevant parameters of the test. On the right, there is a plot showing the irradiation, the ambient temperature, and the water temperature that is increasing during the test. The water temperature starts around 20 Celsius degrees and finished almost in 100. Once the test is finished, the first step in data processing is clustering the recorded data in intervals of 10 minutes, sometimes 5 minutes. In the picture on the right, you can see the intervals that we have plot these vertical blue lines. In the second step, for each interval, cooking power is computed from the variation of sensible heat stored by the water. Then the cooking power for a particular interval in watts is calculated as the mass of liquid, in this case 2 kilos of water, multiplied by the specific heat of the water and multiplied by the ratio between the variation of the water temperature in this interval and the duration of the interval, in this case 10 minutes. The third step is to represent the cooking power as a function of the temperature difference between fluid and ambient. So the cooking power is not a function of time anymore. On the right of the slide, there is a plot of cooking power for intervals of 5 minutes. You can see that the cooking power decreases when the temperature difference between the water and the environment is higher due to increased heat losses, and this is to be expected. But you can also see that there is a first part of the plot where this trend is not observed, and this is due to transient effects that affect the first part of the test. Then the fourth step is the standardization. So the cooker power at each time interval is corrected to a reference value of solar irradiance. Here you can see the formula. So, and on your right, you can see the original cooking power observations, these white dots at this irradiation, the irradiation of the test. And then here you can see the corrected cooking power that is called standard cooking power and is corrected to 700 watts per square meters. So this seems reasonable. So the cooking power, standard cooking power, is proportional to the original cooking power and proportional to the irradiation. So it seems reasonable, but it is wrong. Correct standardization. If we follow the well-established Hottel-Whillier-Bliss HWV formulation, then we found that both cooking power and temperature difference, they both must be corrected for the standard radiation. Not only the cooking power, as the ASAE standard says, but it's the cooking power and also the temperature differences. All those details, formulation details, can be found in this paper. And on the right part of the slide, you can see a plot showing visually how is the correct standardization. For example, this is the original cooking power, and this is the corrected cooking power. And in this case, this original cooking power is corrected to this one. So they are not corrected in vertical anymore. So because also the temperature differences are corrected. And this is the right standard power data, sorry, at 700 watts per square meters. In opinion of the authors, the methodological error of the ASAE standard is clear. In this slide, we can see some consequences of this error. With ASAE standardization, the stagnation temperature for the cooker is approximately the same, whether radiation is almost 1000 or 700 watts per square meters, and this is obviously wrong because we expect that the stagnation temperature will change with radiation. With the Hottel-Whillier-Bliss based standardization, the stagnation temperature is much lower. So in green, this is the linear trend associated with the HWV based standardization, which we say that is the correct one. And this red line is the linear trend associated with the ASAE S580.1 standardization that we believe is clearly wrong. Another consequence is that the standard cooking power at a temperature difference of 50 degrees is overestimated with the data processing of ASAE S580.1. In this example, with the standard, we get a standard cooking power of 87.5 watts is the red one. And with the correct formulation, the standard cooking power is 75.3 watts. So there is a difference. The overestimation is of 16% in this example, which is this is not neglectable. Conclusions. The well-known protocol ASAE S580.1 used to report the standardized power of solar cookers is based on a linear curve obtained from a series of experimental points, but it suffers from a methodological error in the standardization step. The performance of the cooker is mistakenly transferred from the radiation level of the test to the standard irradiation of 700 watts per square meter. the standard cooking power at 700 watts per square meter and delta temperature of 50 degrees, which is the most important measure of performance reported by the standard, is overestimated. We believe that ASAE S580.1 Standard should be revised to address this error. Thank you for your attention.